Hello everyone, welcome to CTP's webinar about our pilots from raw lignocellulosic feedstock to pulping. This webinar will last around 30 to 45 minutes. For today's webinar, I am lucky enough to be joined by two lignocellulosic experts, Ophélia Bernet and Valérie Meyer. Ophélia is a project manager in bio-based material team at CTP with 20 years of experience in chemistry, bleaching, cooking, chemical pulp production, and chemical extraction. Valérie is also a project manager in the same team at CTP with 26 years of experience in biochemistry, microscopy, pulp production, bleaching, cellulose microfibers, and twin screw extrusion. My name is Benjamin Duyege. I am the head of the Bio-Based Material Division at CTP with 10 years of experience in chemistry, polymer science, formulation, and nanocellulose. Just a quick reminder about the confidentiality rules. This digital webinar is strictly confidential and belongs exclusively to the Centre Technique du Papier. It's strictly prohibited to record it, even for personal use, to distribute or rebroadcast it, and of course to resell it without prior written and contractual authorization from the owner, the Centre Technique du Papier. Before getting into the heart of the matter, I would like to give you a brief introduction of CTP. CTP, Centre Technique du Papier, is an industrial technical center in France that creates value to strengthen the positioning of the pulp and paper industry and all over the world. We are developing new materials and new process technologies to help our industry to address new markets. How are we doing so? By carrying out advanced industrial research, exploratory and innovation by consulting, expertise, services, training, analysis, tests, studies, and trials, along with confidential study reports. At CTP, we are around 123 employees with more than 85% in operational department and almost gender balanced. Our turnover is in 2023 was around 11 million euros, with almost 50% in private contract and 50% in public funding, including our collective research program, explorative research, and collaborative projects. In the operational department, the CTP is divided in 5 divisions of excellence. Bio-based materials team, dealing with fibers, plant chemistry, fibers treatment, from the extraction of the molecules of interest from the raw materials, like wood and annual plants, by using thermal, chemical, and mechanical processes, until the structuring of 2D and 3D cellulosic objects like paper, cardboard, molded cellulose, and cellulosic foam. We are also destructuring the fibers to get microfibrillated cellulose to bring reinforced mechanical properties and barriers to grease and oxygen for paper and packaging application. We have also expertise in microscopic characterizations of the fibers to recognize the types of the fibers and their morphology. The functional products team about surface treatment and printing processes is another team of CTP to bring new functionalities to the paper materials, like barrier properties, for example. Another team is called eco-efficient processes, which is about sustainable industry, circular bioeconomy, plant of the future, to decrease the carbon footprint of your processes, for example, by reducing the consumption of energy and water. The fourth team is conformity assessment with 4 COFRAC accredited laboratories in physics, chemistry, microbiology, and sensor analysis. They have also food contact expertise to evaluate the process capability and product performance. And finally, we have also another team dedicated to new works in designing pilots and sensor and maintenance, which is called technical and design. Today's webinar will be focused on the bio-based material divisions. So let's move to the topic of the webinar. From raw lignocellulosic feedstock to pulping, at CTP we have developed a platform of pilots from pulp and paper industry that simulated industrial conditions at demonstration scale of manufacturing chemical pulp, for instance, with the different steps: preparation of the raw lignocellulosic materials, extraction of molecules and fibers by cooking, then bleaching, to give paper pulp to the paper makers that refine as they want for their specific paper application. Everything was possible thanks to funding from La Région Auvergne-Rhône-Alpes, France. From the raw material preparation, Valérie, can you tell us more about what we can do?
Yes, Benjamin, we have the expertise with the use of various types of raw materials, such as wood, annual plants or agriculture residues, for instance, wet straws, flax or sugarcane. Concerning wood, if a customer sends logs or trunks, we can produce wood chips and prepare the raw material for pulping using screening and steaming equipments. You can see here our continuous shipping and screening system equipped with different sieve sizes for an effective removal of oversized and fine fractions of the wood chips. We have also the equipments for thawing and debarking the logs if necessary. Thanks to all these equipments, we can easily prepare the required volume of raw materials for pulping at pilot scale.
Thank you, Valérie. Now, if we move to the second step, extraction of molecule, Ophelia, what is possible to carry it out?
Yes, of course. We have a very nice pilot to extract the molecule from the raw material. So it's possible to turn the condition of molecule extraction and to use different condition, acid, alkaline, neutral, enzymatic medium at different consistency, different chemical charge, different temperature and time. So the goal is to extract some molecule from the wood or for the raw material, such as polysaccharide, lignin, extractives, and etc. With this pilot, it's also possible to cook the raw material, the wood chips or the annual plants, at different temperature with alkaline or acid chemicals or solvents in order to reproduce chemical pulp processing such as kraft, sodium hydroxide, NSSC, low solid, sulfate, dipeptic solvent cooking, compact cooking, or other unconventional cooking. So after this cooking, after the production of in-bleach pulp, it's possible to screen this pulp and thickening tools in order to perform other treatments. So this pilot is unique, and it's possible to introduce 150 kilo of wood chips. It's possible to reproduce industrial process up with a temperature up to 180 degrees with white liquor recirculation during all the cooking. And it's a very flexible pilot. It's possible to validate result from laboratory before industrial implementation, and the pulp quantity produced is sufficient for further simulation, such as bleaching, paper making. So it's a simulation of industrial processes. It's a demo scale validation of new cooking condition, easy to transfer at mill scale.
So thank you very much, Ophelia. We have also even example of testimonials from our customer that called on CTP to perform pilot trials. This is a case from Susano with a quote given by Dr. Bras José de Muner from their Technology and Innovation Department. If I can quote him, We called on CTP to carry out pilot-scale trials to produce special unbleached pulps. We were pleased with the results and would like to carry out further tests on their cooking and bleaching pilots. This was very satisfying. We have also another platform to valorize the co-product of the chemical pulp production and especially for the lignin material, right, Valérie?
Yes, if you are interested in valorizing the lignin present in black liquors or in hydrolysis effluents, CTP can also simulate a lignin production unit integrated in a mill. Thanks to our lignin platform, we have the capacity to produce purified lignin under the form of powder in batches ranging from 100 grams to 5 kilos. This platform is a really versatile tool, enabling to apply either a standardized or your own protocol. Precipitation could be performed using, for instance, pure or mixed CO2 gas, sulfuric or acetic acids under temperatures ranging from 20 to 90 degrees. In addition to lignin samples, you can also get an ID card of your lignin, including physicochemical characterizations such as chemical composition, particle size, and molecular weight distributions.
If we continue with the production chain of manufacturing chemical pulp, after cooking, we can also perform bleaching stage at pilot scale. Ophelia, can you tell us what we can do?
Yes, yes, we have another pilot at CTP to bleach the pulp to reproduce all the bleaching sequences of chemical pulp, such as it's possible to treat this pulp with a different stage, bleaching stage, oxygen, acid, chloride oxide, peroxide with oxygen, ozone, hydrosulfide phase, enzymatic treatment, extraction treatment with oxygen or peroxide, and new treatment to produce bleach chemical pulp. So this pilot, it's possible to introduce 100 kilo of pulp, and it's possible to use different consistency, 3 to 80% at different temperature, up to 110 degrees at 6 bar maximum. It's a very flexible pilot. The volume produced is adequate for additional tests, a test on paper machine or modification, and sampling of pulp which could be distributed by your customers to show their future production. So it's a good simulation of industrial processes with result easy to transfer to the industrial unit.
And in parallel, we have also invested in an innovative process to prepare CTMP, for example, based on twin screw extrusion technology. What exciting things can we do with it, Valérie?
Yes, we can produce fibers from lignocellulosic materials and especially annual plants with this twin screw extruder, which is a continuous all-in-one process allowing either defibrillation, chemical impregnations, bleaching, or molecules extraction. This pilot is very flexible and the extrusion parameters could easily be tuned to the targeted pulp characteristics by adapting, for instance, temperature, screw profile, screw speed, or chemical injection. This extruder enables to produce bleached or unbleached defibered pulp, which could be further refined at high consistency and screened. Here is a picture of the extruder showing from the left to the right the feeding screw, the twin screw, and the barrel surrounding the screw in operating mode. The biomass is introduced through a feeding screw determining the maximal flow rate. Depending on the material density, this flow rate usually varies from 10 to 20 kilo equivalent dry per hour. Then the biomass falls into the co-rotative twin screw equipped with a profile specifically designed. The barrel is constituted of different modules equipped with chemical injection and temperature control. And thanks to the combined mechanical action of the shearing elements, the penetration of the chemicals is very efficient, thus reducing the energy to separate the fibers. Our extruder is a small-size industrial equipment with a large panel of screw elements for conveying, shearing, and mixing operations, and it offers the possibility to design the most adapted profile. So we can produce fibers from wood and annual plants. We can also produce microfibrillated cellulose at high solids thanks to this twin screw extruder. We have also the possibility to extract molecules thanks to our filtration modules and to elaborate new materials by reactive extrusion.
Finally, we wanted also to tell you that we can go beyond and also perform refining tests at pilot scale to evaluate the refining ability of the fibers. So, Valérie, can you explain a little bit more?
Yes, the bleach chemical pulps or defibered pulps needs to be refined to assess the fiber potentials towards paper applications. Our equipments allow to find the best refining conditions for a given pulp by plotting a refining curve to follow the energy versus the fiber characteristics. We can produce pulp batches for fiber or paper characterizations such as optical and mechanical properties, morphological characteristics, etc. CTP can propose low or high consistency disc refining pilot trials to simulate industrial processes. Refining parameters and disc geometries could be adjusted to fit your requirements. Only few kilos of pulp are requested with this refiner, and it also offers the possibility to implement a chemical or enzymatic pretreatment before the refining.
So thank you both of you for this explanation about the different pilots that we have. And all right, we have also presented to you the different pilots available at CTP to simulate your industrial conditions on the pilot scale in order to prepare chemical pulps. But what better way than to illustrate all of this with success stories? Ophelia and Valérie will present to you two success stories that we got recently. Let's start with the first one. Ophelia, can you tell us what happened?
Yes. In the past, a chemical mill wanted to improve their yield and reduce their environmental problem. So they decided to introduce oxygen delignification at the beginning of the bleaching sequences. So at CTP, we perform some trial at laboratory scale and at pilot scale in order to validate some tests and to obtain a very interesting result for the future mill. And on the future mill, they obtain similar result at CTP with an increase of the yield for hardwood pulp, an increase of 25%, an increase of the yield for softwood pulp of 40%, and a reduction of chemical such as chloride oxide and sodium hydroxide, with an improvement of mechanical properties such as tensile strength, tear index, burst, and with a better effluent quality.
Yeah, that's a very good results. And we have also a second stories. Valérie, what happened?
Yes, as you know, lignin solubilized in the pulping black liquors is mainly burnt and valorized as energy by pulp mill. So in this context, Murphy-Kappa asks the CTP to evaluate the relevance of extracting part of the lignin for higher added value applications and possible increase of the pulping capacity, as the boiler could be a bottleneck. The impact of such new way was also evaluated regarding chemical and energetic balance. So CTP produced homemade lignins from industrial black liquors and compare them with commercial ones to evaluate their potential for several applications. Based on the physicochemical characterizations of all the lignins, it was possible to offer Smurfit-Kappa potential applications at several TRL. Phenolic applications appeared of interest regarding the high amount of polyphenols in craft lignin and the maturity of the application. This slide from Smurfit-Kappa shows the main contribution of CTP and highlights the adequation between industrial requirements and work done at CTP, as well as the close cooperation all along the project. We are not only able to produce and characterize lignin, but also model the production unit to calculate all economical and process impacts at mill scales.
So yes, thank you very much for these two beautiful success stories that we got in the past with two customers. So to finish the presentation, I will explain to you how we are working and how we can support your different projects. We are basically working in three steps. The first one is investigations, meaning that we are doing feasibility tests at lab scale to understand units under confidential agreement for sure, by using equipment available at lab scale for the study. Then we move to the validation step. In this step, we are optimizing the conditions at lab scale and improving the process, and then we are validating at higher scale, at pilot scale, by performing these pilot trials before transferring to the industrial site. And the final step, for sure, is the transfer to industrial customers with limited investments, meaning low CAPEX, improving the in-cost production and decreasing in environmental footprint while maintaining the pulp quality. So thank you for your attention. The presentation of the webinar is now over. Thank you again, Ophelia and Valérie, for your fruitful explanation. If you are interested to perform pilot trials at CTP, please contact us, and we wish you a pleasant day. Thank you.